Greetings and welcome. Going to describe a device, the Viscometric Flowmeter, for which I've just received United States patent number 7,644,632. This is the original prototype of the Viscometric Flowmeter, and it works on a pressure differential system. Internally, we have inlet from the outside world and the outlet. Fluids flow in where the pressure can be sensed. They then flow through this coil of, in this case, PEEK tubing, which we found later to be not quite suitable, and then through to the output transducer manifold. In this prototype, they're 3/16 stainless steel. The pressure difference across this loop of tubing is what gives rise to the voltages, which are digitized to then calculate flow rate. It's also essential, though, to characterize the geometry and general resistivity to flow of the tubing, and the temperature was a critical element in doing that, as well as absolute pressure, which the pressure transducers also give you. It's a simple approach. I think that the reason it hadn't been pursued previously was because we had not had 24-bit data acquisition systems available that were so economical. Perhaps this is the reason. In any case, the original prototype, it did fairly well, but we then moved to a, let's turn off this sneaky meter, a more interesting sort of a packaging format for it, where the unit's enclosed in stainless steel, with Ethernet port, USB connectivity, standard COM capability, and PEEK manifolds. I have one of these units here disassembled, and it's basically an arrangement where the guts of the unit slide in. Let's see if I can pull this out. Slide into the stainless steel case, and in this case we used a PEEK, machined PEEK manifold, slightly smaller pressure transducer, and the PEEK tubing is encased inside, in this case it's PEEKsil, tubing inside this thermal jacket, and also in this jacket is a temperature transducer. So the system was basically redesigned in this format. The system will successfully, well, yeah, actually this is serial number 4, October 2006. That's how long it took to get the patent through. In any case, it does need some additional design work done. Things are just a little too tight here to make this exactly commercially viable yet. But the benchtop laboratory flow meter was seen as one implementation of the technology, the core technology. We also see this as being a very good pressure sensing mechanism for HPLC pumps, flow splitters, things like that. A side benefit from the technology is that one can measure viscosity of fluids. Let me just take the camera here and zero in on the drawing in the patent to describe this a little bit better. When we look at the patent, we see here a schematic version of the unit where we have an HPLC pump feeding the manifold, the tubing over which pressure is developed, the output manifold, and here we are feeding a sample injector and an HPLC column. This basic block diagram can be embodied very cheaply. It's 2 pressure transducers and a thermistor or thermocouple, which is thermally coupled to an isolated loop of tubing, or a small straight piece of tubing, and the diameter and geometry can be configured for various flow rates. Essentially characterizing this system over a range of input pressures and operating temperatures and fluid viscosities allows an algorithm to be housed here in the microprocessor, and we're using a PIC 14452, 18452, 18F452 in the original prototypes. But of course, more advanced microprocessors can easily be employed. Essentially, fluid is pumped from any source into the flow meter. The pressure difference across the loop here determines what is determined by the flow rate, very much like sense resistors, like a sense resistor in an electrical circuit. And that's basically what originally inspired the idea here. And that's it. As I said, it's U.S. patent number 7,644,632. I'm John Best. I'm the inventor, and I can be contacted at john@best-instrument.com. I am very interested in continuing to develop and manufacture the flow meter on my own, but in terms of licensing to larger entities, I don't have a legal department, and I'd like to make it available to a company that can really take it to its full potential. The testing apparatus and the algorithms and the development of the thing all can be things that we can go into in further detail in the future. Thanks for watching.